So Unacademy is giving 23%
discount on all subscriptions on the eve of New Year. So avail this and benefit. New Year, new resolution, new goal. Result 2023 by Unacademy. Get 23% off on all Unacademy GATE and ESE civil subscriptions. So you can use my codes GATE Civil. So you'll get 23% flat off on all kinds of subscriptions.
So Unacademy conducting
Mock exams, you can enroll at free of cost. So they'll give you all India rank. Practice with tests curated by top educators. Get detailed performance reports with video solutions. Use code GATE Civil. You can contact for more details. That number mentioned there.
Okay, let us start without wasting time.
Let us go ahead with our content. So the last topic in wastewater engineering is, as per the syllabus, effluent disposal. the last topic.
So some numerical you can expect in GATE exam
For 2 marks.
They keep on asking every year. Effluents means the treated wastewater. After treatment, it's called effluent. That is treated wastewater ultimately disposed back to nature by any one of the following methods. There are 2 ways you can get rid of the waste. Okay? One is disposal by dilution. And second is land treatment. Disposal by dilution means disposing into water course. Disposal by dilution means disposing the effluent into fresh water body. Disposing wastewater into treated wastewater into fresh water course. Treated wastewater into fresh water bodies. To the fresh water bodies, surface water bodies, surface water sources containing sufficient DO, containing sufficient water with enough DO, enough dissolved oxygen. DO means dissolved oxygen. Is known as disposing by dilution, disposal by dilution. Okay? Normally rivers are the best. We dispose back to river, we collect water from river for drinking purpose. We also dispose back all of the waste back to river once we use the water. Okay? Disposal by dilution. So generally the wastewater is allowed to dispose into water course satisfying the disposal standards. So any waste which satisfy the following effluent disposal standards set by Government of India. Disposal standards allowed to dispose into water course. That's called disposal by dilution. So we have got effluent disposal standards set by Government of India. Who has given? Government of India. Effluent disposal standards into water course. As per Government of India norms. Effluent disposal standards. So 4 parameters you need to be cross-checked and verified prior to disposal. What are those parameters? Of course, the very important parameter is BOD. Next important parameter is, for certain waste BOD cannot be measured. For such waste we measure COD. In addition to that, solids, oil and grease also we measure. Okay? Those 4 parameters you have to cross check and verify prior to disposal. 4 parameters are there. Okay? I am talking about only domestic waste. I am talking about only domestic waste. This is parameter disposal standard given by Government of India in milligram per liter. So one is BOD. This is only domestic wastewater disposal standard for domestic waste. Industrial wastewater standard is different. Of course, there is no much difference. Standard for domestic waste. Domestic wastewater only dangerous, okay, compared to industrial waste. See what? Because it contains more biodegradable matter. So wherever biodegradable matter is there, such waste is dangerous. Then one more parameter we measure is oil and grease. Another parameter is total solids. So these 4 parameters we work out for any waste. So BOD should be preferably less than 20 milligram per liter. Okay, COD should be preferably less than or equal to 250 milligram per liter. So COD include oxygen demand of biodegrades, oxygen demand of non-biodegrades. Oil and grease preferably less than 10 and total solids preferably less than 100 milligram per liter. If BOD is more, so it also pollute water body. If we dispose more than 20, chances of revival of, chances of getting rid of this waste after disposal is very, very less. But if it is 20 or less than 20, again over a period of time this becomes 0. So BOD become 0, COD becomes 0, oil and grease become 0, total solids also become 0. That is what is called self-purification. So that is what we need to work out. The leftover substances present in wastewater, they are removed in due course of time by water body on its own, known as self-purification. That's what we need to work out. First we study self-purification capacity of water body. Truly speaking, this topic you need to study before treatment, wastewater treatment. Self-purification of water bodies. This topic we need to study disposal, effluent disposal prior to wastewater treatment. The reason being, so once you know the self-purification capacity of water body, if self-purification capacity of water body is less, then we need to apply more effort. Self-purification capacity of water body is more, from our side less effort is sufficient. See now, self-purification capacity is something similar to immunity of a human beings. So immunity levels for youngsters, it is very, very high. Immunity level for old people like me, it is very, very low. Suppose if old people more affected by coronavirus or some kind of problem, so chances of survival or chance of revival is very, very less. So doctor has to put lot of effort externally. But youngsters, even
they are infected by any kind of disease, their body has got so much resistance, they can fight against the problem. Unless it is very severe, so usually for youngsters, resistance power is more, they can easily get rid of the problems. Even without medication also they can be cured. That's called self-purification. But too much is there, even youngsters also hospitalized. So beyond its capacity, beyond its immunity level, beyond body resistance, any disease surfaces, then only we go and join in hospital, we require external medication and all. So within its capacity, if any problem, health problem happens, body recover on its own. During night time when you sleep, body repair its parts. So whatever repairs are required, whatever recovery is required, body take care of on its own. So you need not go to any hospital, you need not consult any doctor also. Understood? Automatically it happens. Automatically body can recover. That's called self-purification. So leftover substances present in that is small amount of biodegrades, small amount of COD, oil and grease, total solids present in wastewater, they can over a period of time they can be removed completely from water body known as self-purification. Leftover substances present in effluents, are removed by water body on its own. Known as self-purification capacity of water body. Self-purification of water body, known as self-purification. Okay? Self-purification of water body occurs due to following mechanism. So following mechanisms are responsible for self-purification of water body. Okay? One is dilution. Second one is dispersion. And third one is dilution, dispersion. Third, sedimentation. Fourth, oxidation. Because of all these mechanisms, they purify. Fifth, reduction. And sixth, sunlight. Because of all these, sunlight carry disinfection of what organisms. Okay, what it does and all we'll see. Because of all these, water bodies are self-purified. Dilution and dispersion, both of them reduces concentration of substances present in water body. Dilution means what? Mixing small amount of effluent into large water cores. So mixing small amount of effluents in large amount of fresh water body. Reduce concentration of substances in effluents. Reduce concentration of. So dilution reduces concentration of substances in wastewater. Suppose there is a big river flowing nearby, carrying fresh water. This is a river. Okay. This is upstream side of the river. This is downstream side of the river. A stream of wastewater. So you are disposing bad waste into this river. This is effluent or wastewater. So QW amount of effluent
with concentration of substances Cw, you disposed into water course, and the upstream side it is pure only. So amount of water flowing on the upstream side is Qr, with concentration of that substance on the upstream side is Cr, let us assume. Then after immediately disposing into a river, assume river flowing in this direction, upstream to downstream it is flowing. Okay? After disposal what happens? Its concentration becomes C mix. That C mix is slightly much lower than Cw, slightly more than Cr. Concentration of that substance in river. It could be any parameter. It could be BOD, or it could be right COD, or it could be oil and grease, or it could be total solids, whatever it may be. Their concentration decreases after disposal. So one question they are asking continuously in competitive exams, especially GATE exam. One question they are frequently asking based on mix formula. So when two different solutions having two different concentrations, if you mix with each other, what happens? You can write mass balance equation. From that you can find out concentration of mix. After mixing, concentration is equal to Q river into C river plus Q wastewater into C wastewater by Q river plus Q wastewater. On the downstream side what will flow? Q river plus Q wastewater flow on the downstream side. Its concentration is C mix. Mass in is equal to mass out. Mass balance equation also. This is the point of disposal. You are disposing at this point. Okay? So that is based on this equation. They keep on asking questions in GATE exam. Only one chance. Only this based on this equation. So after mixing, what happens when you travel further on the downstream side? You travel more and more on the downstream side. Suppose at some point when you have been asked to find out at some distance on the downstream side, so and so kilometer distance on the downstream side, you work out its concentration on the downstream side. Then its concentration further decreases. That C mix become somewhere here you are working out. So its concentration becomes CT. So this CT value, concentration of that substance on the downstream side. Concentration of substance on downstream of point of disposal. On the downstream of point of disposal is equal to, it is CT, which is equal to C mix into, it exponentially decreases at the rate K. So E power minus KT. So based on these two equations, they keep on asking questions in both GATE exam and GATE exam especially. ESE exam only C mix question. GATE exam this also is coupling this with this. Because GATE calculator is allowed, therefore he is asking some tough questions in GATE exam. So remember, for GATE these two formulae are very important. Based on these two only, is keep on framing questions in this course, in this topic. Okay. Second thing what happens? Dispersion. Even dispersion also reduces concentration. Dispersion means spread. So it also reduces dispersion occur due to wind currents. Also reduce concentration. But there is no numerical equation. Luckily, of course, numerical equations are there. Both dispersion, dilution coupled together. Gaussian model is there. Gaussian distribution model you can apply. But generally, dilution only reduces much concentration. Dispersion almost become negligible after dilution. Therefore, it is not taken into account. So, of course, it do help in further reducing the concentration. Then, sedimentation occur, solids present in water body. Large water body act as a big sedimentation tank. Large water body act as sedimentation tank. Therefore, solids in water course they settle down. Therefore, that's the reason why solids you need to, if it is more than 100, if they settle down at bottom, carrying capacity of water body decreases, depth decreases. Therefore, it should be less than 100. Therefore, solids settle down. Self-sedimentation also occur. Oxidation. Oxidation means what? Aerobic decomposition of biodegradable matter. Aerobic decomposition of biodegrades using oxygen present in using DEVA of water body. Dissolved oxygen in water body consumed and biodegrades are decomposed. Even after oxidation, still biodegradable matter is there, then reduction will occur. It is anaerobic decomposition of biodegrades which occur after oxidation. All oxygen is used up, no more oxygen is there, then anaerobically it is decomposed. Decomposition of biodegrades. Okay? Then sunlight. Sunlight, what it does? Disinfect water body. Disinfect water body by using that UV radiation present in sunlight. So that is how water body self-purified. So if at all they ask anything, that is questions on C-mix equation and CT equation. C-mix and CT. So here you are supposed to be careful. These two you are supposed to be very thorough. Remaining things light in this topic. Especially GATE exam I am talking. Very good questions they are asking in GATE exam. Let us try to work out some questions, numericals. Let us work out, okay? Shall we go ahead with numericals? Are you ready? Okay. So drain carrying sewage of BOD 200 milligram per liter and flow rate 50 meter cube per second, 50 meter cube per second, joins a river whose upstream flow rate, whose upstream BOD is 8 milligram per liter and flow rate is 500 milligram per liter. Assume immediate and complete mixing of brine. Assume immediate and complete mixing of brine with the river. What is the estimated downstream BOD of the river flow? What is the estimated downstream? DYS means downstream is given. UYS means upstream. Downstream BOD of the river. Come on, work out. He has given options: A 20.4 milligram per liter, B 25.4 milligram per liter, C 104.4 milligram per liter, D 70.4 milligram per liter. Come on, work out. Give me the answer. So what to do? How to do? Mix formula, that's all. He is asking what is BOD of the mix, fully speaking. This is a river. So is disposing Q amount of wastewater, 50 meter cube per second. With the BOD of wastewater is, how much is given BOD of wastewater? 200 milligram per liter. See now, 200 milligram, that means it is untreated almost. Untreated waste we should not dispose actually. This is upstream side, this is downstream side. So upstream side river flow is 500 meter cube per second. With the BOD of river is 8 milligram per liter. And he is asking what is concentration of BOD on the downstream side immediately after mixing. So immediately at the point of disposal he is asking. Yes means second only, okay? Here is asking what is Y mix. Come on, this is a river. So what is Y mix formula? BOD after mixing is equal to, C could be any parameter. Q river into Y river, Q wastewater into Y wastewater by Q river plus Q wastewater. The only thing that you need to remember is all Q's and all C's must be same unit system. So Q meter cube per second, milligram per liter, milligram per liter. So comfortably you can substitute in this equation. Q river is 500, Y river is 8, Q wastewater is 50, Y wastewater is 200 by 500 plus 50. So which unit system you get? Milligram per liter only you get. Because meter cube per second cancel out. Can work out answer? So it is 500 into 8 plus 50 into 200 divided by 550. So it is 25.45. So I got 25.45 milligram per liter. So that is answer for this question. Let us verify that the option is there. Yes. So this option is matching there. That is the right option. Okay? Here now you have to give answer to me. No one is there, no one following live class. Okay? Ankit Kumar is missing. Dr. Israr, Nanda Kumar. Some are regularly attending the classes, but today they are not there. Okay, anyway. Let us try one more question. Example 2. In a certain situation, water discharged into a river mixes with the water, wastewater, not water. This is wastewater. Wastewater discharged into a river mixed with the river water instantaneously. And completely. Following data available. Wastewater DO 2 milligram per liter. Discharge rate 1.1 meter cube per second. River water DO 8.3 milligram per liter. River water flow rate 8.7 meter cube per second. Initial amount of DO in the mixture of waste and river shall be that means he's asking indirectly DO mix. Come on, work out DO mix. He's asking DO mix. Answer. So again same type of question. Instead of POD now it is DO. So there is a river flowing nearby. Okay. He is disposing waste here. And DO of wastewater is this much. Into river on the upstream side. DO of river on the upstream side is this much. Then what is DO mix is asking immediately after mixing. So QW is given as 1.1 meter cube per second with the DOW 2 milligram per liter. You don't find much DO in wastewater. River water 8.3 milligram per liter. DO 8.7 flow rate. 8.3 milligram per liter. So it is flowing from upstream to downstream. So DO mix immediately after this. Can work out. So DO mix is equal to, instead of Y mix, DO mix here. So Q river into DO river plus Q wastewater into DO wastewater by Q river plus Q wastewater. So it is 8.7 into 8.3 plus 1.1 into 2 by 8.7 plus 1.1. So straight will get milligram per liter. Come on, work out. So 8.7 into 8.3 plus 1.1 into 2. So it is 7.59 milligram per liter. So immediately after mixing, its concentration is 7.59 milligram per liter. But the options given here, one of the options given is 7.6. So it is rounded to 7.6. Options given here. Options given are 5.3, 6.5, 7.6, 8.4. So answer is 8.6, 7.6. Okay? So that is how we can work out using mix formula. Next, let us see such type of simple questions you can't expect. So a little bit twist will give you. So example 3, this question has been asked in GATE 2014. It's a very good question, and similar type of question couple of times repeated also. A wastewater stream is given like this. I am writing as it is with ultimate BOD (90 milligram per liter) is joining a small river. Flow is equal to 12 meter cube per second. Ultimate BOD is equal to 5 milligram per liter. Both water stream, both get mixed up instantaneously. Both water streams, that means wastewater and river water, get mixed up instantaneously. Cross-sectional area of cross-sectional area at the river is 50 meters square. Assuming deoxygenation rate constant, K is equal to 0.25 per day. As given, per day means day inverse only. The BOD milligram per liter of the river water 10 kilometers downstream of the mixing point is. Interesting question. Downstream of the mixing point is. He has given options A 1.68, B 12.63, C 15.46, D 1.37. So 4 options are given. So you have to tick mark whichever is right. 2 marks question in GATE exam this is. Similar type of questions many times they have asked. And much, of course, with much clarity they have asked. In this question some clarity is missing, but still with much clarity they have asked. 15.46 this is. Come on, which is the correct answer? Work out. Read question properly, then you will get idea. Then using that you can find out. Come on. Completed? At least get idea, read question properly. So he is not asking immediately after mixing, he is asking 10 kilometers after mixing. Okay? This is a river. So there is a river flowing. So they disposed waste QW with ultimate BOD of waste L0W. QW is 2 meter cube per second with L0W is 90 milligram per liter, given in the question only. Into river, on the upstream side it is Q river and L0 of river. Suppose upstream side not given L0, we will take 0. So whichever is not given, that is taken as 0. 12 meter cube per second and L0 on the upstream side of the river is L0 of river is, everything we work out in terms of ultimate only, 5 milligram per liter. So this is upstream, river flowing from upstream to, this is downstream. He is not asking immediately. Immediately means what will work out? L0 of mix will work out. But he is asking where 10 kilometers on the downstream side. 10 kilometers on the downstream side, what is LT concentration? Concentration of BOD. BOD remaining in river water. Not BOD removed, BOD remaining. You are finding status and condition of river. So therefore LT you have to find out. So what happens? What I told you. So after mixing it is L0. As time progresses, L0 mix. As time progresses, it exponentially decreases. Here it is L naught mix immediately after mixing. At 10 kilometers point, its value may be this much. So you have been asked to find out this. What is LT at 10 kilometers point after mixing? So first of all, what you have to work out? L naught of mix. L naught of mix is equal to Q river into L naught of river. Q wastewater into L naught of wastewater by Q river plus Q wastewater. So Q river is given as 12. 12 into 5. Q wastewater is 2. 2 into 90 by 12 plus 2. Where is 12 plus 2 flowing? On the downstream side. This is QR plus QW. This is 14 meter cube per second. That is flowing on the downstream side. Okay? On the downstream side flow is 14 meter cube per second. K value is given as 0.25 day inverse. Cross section area of river also given. Why cross section is given? I will tell you. So this cross section area. So cross section area here. So this cross section is 50 square meter is given. River what? River. So you get L naught mix. What is L naught mix value? This 12 into 5, 60 plus 190. 180. 90 into 2, 180. 240 by 14. So it is 17.14. So as you travel further downstream side, what happens? L naught mix value decreases at a rate what? E power minus kT, exponentially decreases. So at 10 kilometers point to travel, how much time it will take? That time value substitute K value in this equation, L naught mix, then you will get at 10 kilometers what amount of BOD remained in the river. Okay? So T you have to find out. Time taken by the river water to travel 10 kilometers. T, that is. T means time taken by the river water to travel 10 kilometers. So time taken by river water to travel 10 kilometers on downstream side is taken as T, which is equal to, how to find out time taken by river water? Right? Distance traveled by velocity of flow. Distance traveled by velocity of flow. So distance traveled is 10 kilometers, right? 10,000 meters. Velocity of flow, you can take it as or length of the river by velocity of flow is Q by area. This is taken as length of the river, L value. So L into cross section area. So it is area into length by Q. What is Q? Q mix this is. Okay? What is Q mix? This is Q mix. Q mix is equal to QR plus QW. So Q mix is equal to QR plus, after mixing, QW, this 12 plus 2, 14 meter cube per second. Therefore, distance travelled by, time taken by river water to travel 10 kilometers is equal to how much? Cross section area of river 50, length of river 10,000 meters, 10 kilometers means 10,000 meters by 12 plus 2, 14. So we'll get answer in meter cube per second. So this is meter square into meter by meter cube per second. We will get answer in seconds, but I'll convert this into days because K value given in days by 24 into 60 into 60 days. So if we convert into days, how many days it will get? So work out 50 into 10,000 by 14. So I got this many number of seconds, 35,714.28 seconds. You want to convert this into days, you have to divide by 24 into 60 into 60. So it is 0.41 days. 0.413 days time it is taking to travel. Okay, therefore BOD of river water at 10 kilometers downstream is equal to, it is L 10 kilometers, nothing but LT is equal to L naught mix into e power minus k into t. So which is equal to L naught mix we got already 17.14, 17.14 into e power minus 0.25 into t is 0.413 days. So this will give how much amount of B would remain in river water after traveling 10 kilometers on the downstream side. So 17.14 into e power minus 0.25 into 0.413. So I got exactly 15.458. So this is rounded to 15.46 milligram per liter. So that was the answer for this question. So let us see options are there or not. 15.46 option is there. So C option is matching. So that is how we can work out. Clear this question? Very good question this is. Watch out this once again solution. This is a river system. So this is how we can work out questions from this topic. One more question let us try. This is also asked in GATE exam. So last year, I think before last year also, there are some questions. Let me check. Let me find out question, one more question. This year or last year GATE exam, where similar type of question is been asked. February.
2021 GATE exam, I think one more question is there. Let me find out. Meanwhile, you go through this solution, okay? Okay, anyway, I'm not finding. Well, let us take one more question. So this question also, this is also simple question, not so difficult. Example 4. Secondary effluent means secondary treatment plants. Effluents coming from secondary treatment plants are called secondary effluent. Secondary effluent from a municipal wastewater plant is discharged into a stream at a rate of 12,000 meter cube per day. At 20 degrees Celsius with a BOD 5 of 50 milligram per liter. A DO concentration of 2 milligram per liter. Full stop. The stream flow estimated to be 40,000 meter cube per day with BOD 5 of 3 milligram per liter and DO 7 milligram per liter at 20 degrees Celsius. Assume a decay constant for the mixer to be K is equal to 0.23 day inverse to the base E. Estimate first question BOD of the mixer. Second question ultimate BOD. Third question DO of the mixer. This question has been asked in GATE 97 exam.
This is asked in GATE 97. Of course, that time questions were asked for 5 marks. 3 questions, each carry 1.5 mark, 1.5 mark, something. Come on, work out. First part is easy only. What is first part? BOD of the mixer. He has given 2 things. River and wastewater. Q river is given as 40,000 metric cube per day. Y river is given as 3 milligram per liter. And DO of river is given as 7 milligram per liter. Q of wastewater is given as 12,000 metric cube per day. BOD of wastewater is given as 50 milligram per liter. And DO of wastewater is given as 3 milligram, 2 milligram per liter. Sometimes you don't find also. If any of the thing missing, DO of wastewater missing means we take 0. Or BOD of river is missing means we take 0. Generally in river, on the upstream side, you don't find any BOD. If at all it contains, it will give you. Generally wastewater doesn't contain much oxygen. If at all it contains, it will give you. So BOD of river on the upstream side and DO of wastewater, if not given, they are taken as 0 comfortably if required. Okay, remember that point. So I have been asked to find out what first one. BOD of the mixer. Y mix is equal to this Q river into Y river plus Q wastewater into Y wastewater by Q river plus Q wastewater. So Q river is given as 40,000 metric cube per day. Y river is given as BOD of river water 50. Oh sorry. BOD of river water is 3. Mixed with 12,000 metric cube per day of wastewater with BOD 50. So all Q's must be in same unit system, all Y's must be in same unit system. That only have to ensure every time. If they are given different unit system, you have to convert them. So it is 40,000 into 3 plus 12,000 into 50 by 52,000. So it is 13.846 milligram per liter. Similarly, so this Y mix is equated to this L naught into 1 minus e power minus kT. So BOD 5. So T is taken as 5. K into 5. So since it is BOD 5, 5 day BOD of the mix this is. Therefore, so this is taken as T is taken as 5. Since it is 5 day BOD. Okay. So L naught is asking ultimate BOD. Therefore, ultimate BOD L naught is equal to, it is Y mix by 1 minus e power minus k into 5. That's all work out. Y mix we got 13.846. So L naught is equal to 13.846 by 1 minus e power minus k value given in the question. What is k value? 0.23 day inverse minus 0.23 into 5. So and so milligram per liter we get. Come on, work out. Like BOD problem this is. 13.846 by 1 minus e power minus 0.23 into 5. So it is 20.26 milligram per liter. That was the answer for this question. Okay. And one more thing you have been asked to find out is DO mix. So DO mix is equal to Q river into DO river plus Q wastewater into DO wastewater by Q river plus Q wastewater. So Q river is 40,000, DO of river is 7, Q wastewater is 12,000, DO of wastewater is given as 2 by 40,000 plus 12,000. Come on, how much it is? $40,000 into 7 plus 12,000 into 2. Divided by 52,000. It is 5.846 milligram per liter. That was the answer for this question. Okay? You can comfortably work out the problem. So like this, they ask questions in exam. You can comfortably work out. In addition to that, one more question he asked in GATE exam is initial deficit. So the terminology you have to understand. So during self-purification, purification of rivers. So two things occur in river water. Occur in water body. River water body. One is called deoxygenation. That is, DO levels drop down, depletion of oxygen. Second one is reoxygenation. Why reoxygenation occur? Because water body exposed to atmosphere. Deoxygenation occur due to disposal of effluent. Because bacteria present in that effluent use oxygen present in water body, depletion. And because of continuous exposure to atmosphere, reoxygenation also occurs. That is called replenishment of oxygen. So one side oxygen is used up, other side oxygen is filled up. Okay? That the usage is called deoxygenation, filling is called reoxygenation technically. After disposal I am talking, two things happens. One is deoxygenation. DO levels in water body if you measure after disposal with the time. On the other hand, reoxygenation also occur. This is reoxygenation. So depletion of oxygen occur at one hand, reoxygenation, deoxygenation. This is reoxygenation. See, both of them if you join together, if any river is pure, see, it's supposed to contain oxygen levels at saturation, highest level, but no river is pure. Therefore every river has got certain deficit of oxygen. This is called oxygen at saturation point. This is saturation point. So the difference between this deoxygenation, reoxygenation, if you sum up, then what happens? You get one curve. That curve is called oxygen sac curve. That is the basis to measure stream pollution, river pollution. What will you get? Deoxygenation rates and reoxygenation rates if plot, you get one curve called oxygen sac curve. That oxygen sac curve is the basis to measure stream pollution. So if you take only oxygen sac curve, so the ordinates above oxygen sac curve will give this is critical deficit of oxygen at any time t. Right? initial deficit is this much. This is D naught. Deficit keep on increases, again keep on decreases. So this deficit we try to find out. That initial deficit question one time in GATE exam they asked. So if you take only oxygen sac curve, DO versus time plot if you make, after disposing the waste, this is a river, right? You are disposing your waste here. Q amount of waste into this water course you are disposing. The water flowing on the upstream side is QR amount of water. So on the downstream side you are working out DO levels. So you work out DO levels on the downstream side. If river is pure, it's supposed to carry oxygen at what? Dissolved oxygen at saturation, this saturation point. Because this is saturation point. No river is pure. So every river has got some deficit. So the deficit after disposal what happens? Keep on increases. Again it keep on decreases. This is called oxygen sac curve. We got this oxygen sac curve. So oxygen levels on the river, DO levels on the downstream side. If you plot, then you get oxygen sac curve. So DO at any point of time on the downstream side is equal to, this is DO at any time on the downstream side. DO in river water at any time on the downstream side is this is. DO at any time on the downstream side. DO at any time. Okay? Initial DO supposed to be at saturation, but DO at any time is this. Then the difference between DO saturation and DO at any time is called oxygen deficit at that time. This one is called deficit of oxygen. What do you call this one? Deficit of oxygen at any time t. This is dt. So that the initial deficit is how much? This is d naught. Deficit keep on increases. Deficit become maximum at one point of time. Deficit is maximum at some point of time. That point is called critical deficit. Where deficit is maximum, that point is called critical deficit point. So where deficit is all time low, that is. Wherever deficit is very very low, the point is called critical deficit point. Okay? This is critical deficit. So once river crosses that critical deficit point, it is fast in the path of recovery. So up to this critical time, this critical deficit occur where? At critical time Tc. It occur at critical time Tc. This is time plot only. So till it crosses critical time, this portion of the river is heavily polluted portion. Heavily pollution occur here. Till it crosses that critical time, so river is heavily polluted. This critical time. This heavily polluted zone of river after disposal. Heavily polluted river. This is heavy pollution occur in river. In this portion, river is recovering fast. This is recovery zone. Recovery from pollution. That is fast occurring because in this zone, reoxygenation is more. Deoxygenation in this zone, deoxygenation is more, reoxygenation is less. So therefore, the recovery of pollution. This is. That is how it self purify. So now oxygen levels decreasing, again oxygen levels increases to original value. So that is how. So initial deficit question they are asking. So they are called, these equations are called Streeter-Fels equation. So deficit of oxygen at any time t, dissolved oxygen at any time t on the downstream side, DO at any time t on the downstream of disposal, on the downstream of point of disposal is equal to, it is DOT, which is equal to DO sat minus DT, where DT is equal to oxygen deficit at a time t, oxygen deficit on downstream at a time t, oxygen deficit at any time t on the downstream side, on the downstream of disposal. Okay? To find out this oxygen deficit, there is one equation, big equation is there. That equation no way they will ask. So it is K1 L0 by K2 minus K1 It is called Streeter-Phelps equation. Okay. Deficit at any time t is equal to, it is K1 L0 by K2 minus K1 into e power minus K1t minus e power minus K2t plus d naught into e power minus K2t. So in this equation, if you substitute, you will get that dt. This equation is called Streeter-Phelps equation. To find out oxygen deficit at any time t, this equation is known as Streeter-Phelps equation. Okay. So in this equation, so L0 is, how to find out L0? L0 is equal to, it is Y mix by 1 minus e power minus K1 into 5. And D naught is initial oxygen deficit. Initial oxygen deficit. This initial oxygen deficit we work out by using equation. So initial oxygen deficit D naught is equal to, it is DO sat minus DO mix. This question has been asked in GATE exam. What is initial oxygen deficit? Okay. What is K1, K2? K1 is known as deoxygenation rate constant to the base E, like a BOD constant only. Deoxygenation rate constant. It is taken as D inverse, and K2 is reoxygenation rate constant. At what rate oxygen is depleted, at what rate it is refilled. This is also expressed in day inverse. That's all. K1, K2 are constant. If you substitute, you can find out deficit at any time. If you know deficit at any time, you can find out dy at any time. These equations are called Streeter-Phelps equation. One time in GATE exam, they asked that d naught. That question is not there with me. Otherwise, I would have solved that question to you. In 2020 GATE exam, that question has been asked. Let me verify. Let me see in the internet. 2020 Civil GATE question paper. Let us solve that question, okay? Let me find out first question. One minute, I am verifying question paper. 2020 GATE question. That question has been asked. Initial oxygen deficit. 2 marks question, so simple and so easy that is. This question also you got. Two questions are there from there. From this topic, 2 questions has been asked in 2020. Same topic. GATE 2020. Yes. Right, I got it. So let us solve one question. Example for a 5 GATE 2020 afternoon session paper. A river has a flow of 1000 million liters per day. 1000 mld BOD 5 milligram per liter and dissolved oxygen 8 milligram per liter before receiving the wastewater. Wastewater discharge at a location. The saturation DO level is 10 milligram per liter in the river. This is also given. Wastewater discharge of 100 mld with the BOD 5 of 200 milligram per liter. 100 mld with the BOD 5 of 200 milligram per liter and DO level of 2 milligram per liter. Falls at that location. Falls at that location means discharge at that location. Assuming complete mixing of wastewater, we don't require all this data. Whatever we require that only we take. Assuming complete mixing of wastewater and river water. The immediate DO deficit in milligram per liter is dash. 2 marks question this is. Simple now? So DO deficit. Immediate DO deficit means what? DO? D naught. Initial oxygen deficit after mixing. Initial is asking initial oxygen deficit immediately after mixing. Immediately after mixing. Mixing means what? After disposal. River wastewater with river water. That is D naught, which is equal to DO sat minus DO mix. That's all. Only one thing you have to find out. DO sat is given in the question. That is 10 milligram per liter. So only one thing you have to find out. DO mix you have to find out. How to find out DO mix? This is unknown. DO mix is equal to Q river into DO river plus Q wastewater into DO wastewater by Q river plus Q wastewater. All Qs must be in same unit system. So you are mixing two things. So DO mix is equal to 1000 mld with the DO. How much it is? 1000 mld with the DO 8 milligram per liter. 100 mld of waste. 100 ml, no? With the DO 2 milligram. So all Qs are in mld, concentrations are milligram, so no issue. They should be in same unit system. So you get milligram per liter only. Because you get answer in mld milligram per liter by milligram per liter. Numerator mld into milligram per liter by denominator mld. So mld get cancelled. Then you get milligram per liter answer. Understood? So 1000 into 8000 plus 200. 100 into 2, 200 by 1100. So it is 7.45. 7.454. milligram per liter. Okay? Then initial oxygen deficit D naught is equal to, it is DO sat minus DO mix. So DO sat is given 10. After mixing it is 7.454. So how much is there? 2.545 or 546 milligram per liter. That was the answer for this question. Initial deficit is 2.546 milligram. Remaining things are not required for us. So this is how you can work out problem. One more question is there in the same year. Similar type of question was solved already. So now in the same paper, 4 marks came from this topic. Just from this topic. So I'll write this question, you try. Example 6. This is also GATE 2020. Okay. A stream with a flow rate of 5 meter cube per second, having an ultimate BOD of 30 milligram per liter. Wastewater discharge of 0.2 meter cube per second. 0.2 meter cube per second, having a BOD 5 of 500 milligram per liter. Joins the stream at a location and instantaneously gets mixed. Instantaneously gets mixed up completely. The cross-sectional area of the stream is 40 square meter. Why it is given, you know, which remains constant throughout its length. Anywhere it is 40 only. BOD exertion rate constant is, that is BOD rate constant. What is that K value? Constant is 0.3 per day to the base E. The BOD in milligram per liter remaining at 3 kilometers downstream from the mixing location is. Similar type of question but slightly different. Carefully need to work out. First only will go wrong. You are not careful, first step only will go wrong. Dash milligram per liter, of course. So what is the thing where you go wrong? For wastewater he has given 5-day BOD. For river water he has given ultimate BOD. See now, BOD 5 wastewater. For river water ultimate BOD is given. Okay? So that is where you should supposed to be careful. All should be in same unit system. So Q river is given and ultimate BOD of river water is given and Q wastewater is given and 5-day BOD of wastewater is given. So if you mix, it is neither Y mix nor L naught mix. Therefore, either you have to convert YW into L naught W or L naught river into Y. But anyway, ultimate BOD, in terms of ultimate BOD, let us work out because BOD remaining is asking. So where he is asking at 3 kilometers downstream is asking. At 3 kilometers downstream, what is BOD remained? So BOD remained at any time is equal to what? So it is L naught mix into e power minus KT. So I will convert YW into L naught W. Then I will work out this problem comfortably. Cross section area is given as 40 square meter. This cross section of river. Then K of river is given as 0.3 day inwards. So this is downstream side. Downstream side how much flowing river? So this is 5 meter cube per second. 5 meter cube per second with BOD ultimate BOD 30 milligram per liter. And QW is 0.2 meter cube per second. This is okay. Sometimes this also will give MLD or liters per second. Then you have to convert. So ultimate BOD is 5-day BOD is 500 milligram per liter. This is 5-day BOD. So YW I convert into L naught. YW is equal to, it is L naught W into 1 minus e power minus KT. T is 5 days, 5-day BOD it is. So L naught W is equal to, it is YW by 1 minus e power minus K into 5. Come on, work out this is. So YW is given as 500. This is 500. By 1 minus K value is given as 0.3. Into 5. So I'll get L naught W. I worked out this. Then I can find out here L naught mix. Then I can get that. Like last question. Understood now? So small twist you put there. Compared to last question we have solved. 1 minus e power minus 0.3 into 5. Six part 3.60 this is. This is 643.60. 643.60 milligram per liter. Now we can find out L0 mix. After that it is simple only. So L0 mix is equal to Q river into L0 of river, Q wastewater into L0 of wastewater by Q river plus Q wastewater. So 5 meter cube per second into 30. This is 0.2 meter cube per second, but L0 W is 643.6. 643.6 by 5 plus 0.2. Come on, how much it is? Into 0.2 plus 5 into 30 by 5.2. So it is 53.6. L0 of mix is 53.6. So time taken to travel 3 kilometers is distance traveled by velocity of flow. Distance traveled is length of flow. This is taken as length of flow. This cross section area. So length of flow, velocity of flow is this Q mix by area. Q is equal to area into velocity. Velocity is equal to Q by area. That's what I am doing. So it is area into length by Q mix. What is Q mix? Q river plus Q wastewater. That is flowing on the downstream side. So 5 plus 0.2, 5.2 meter cube per second. So again you will get T value 40 square meter. 3 kilometers means 3000 meters. By 5.2 seconds will get. To convert this into days, why? Because K value given in days. If K value also given 1 by second, then seconds also you can substitute. Then you can convert this into days. T value in days. Can't work out T value in days. So 40 into 3000 by 52. 5.2, sorry. By 24 into 60 into 60. So it is 0.267 days. Therefore, L at any time is equal to, it is L0 mix into e power minus k into t. So L at 3 kilometers point is equal to, it is L at L. 3 kilometers to travel, how much time taking? 0.267. 0.267, which is equal to L0 mix into e power minus k into 0.267. Let us substitute. L0 mix is how much we got? 53.6. So 53.6 into e power minus k value given in the question. K value is given is 0.3 day inverse. 0.3 per day into 0.267. So straight will get answer in milligram per liter. That was the answer for this question. So it is 53.6 into e power minus 0.3 into 0.267. So it is 49.474. So still this much amount of B word remain. Only little B word is removed after traveling 3 kilometers. So some more distance you travel, it obviously keep on decreases exponentially. Okay. So this is how we work out the problem. So I completed this topic, what possible questions you are expected from this topic completed. One more thing is that theory, that is land treatment. Land treatment means land disposal. Disposing sewage effluents. Disposing sewage effluents or a piece of open land. Open land is known as land treatment. Even in case of land disposal also, self purification occurs. So this method is practiced only when in the absence of water body. Only when in the absence of. So this is not recommended. Land treatment or the dilution only best method. In the absence of fresh water body in the close vicinity of a community. In the close vicinity, in the close surroundings, no fresh water body is there, no river is there, then there is no option left with you, you have to go for land treatment. Land disposal is less recommended. The reason being, land is very costly, precious, we don't want to pollute land, we don't want to pollute groundwater also. Therefore, this is less recommended compared to disposal by dilution. Rivers carry huge water, even if it dispose also, fast they recover. Land do recover, but self-purification capacity of land is less compared to self-purification capacity of river. This is open land, which is, open land means what? It straight away get exposed to sun. This is a land, so we spread sewage effluents on the piece of land. Open land like this. These are the effluents. So its thickness should not be more than 20 centimeter. So when this get exposed to sun, what happens? Most of the liquid evaporates. Evaporation occurs, no? So most of the liquid evaporates. Evaporation occur, and remaining things percolate into ground or infiltrate into ground. That infiltrated thing again subjected ground content pore spaces, naturally filtration occur, and in the pore spaces some of the impurities settle down also. Sedimentation also occur. Sedimentation and filtration and oxidation. First filtration, then oxidation. So soil contain bacteria, soil bacteria degrade, soil bacteria takes care of biodegrades. Soil bacteria decompose biodegradable organic matter aerobically. Decompose biodegrades present in effluents. Because the top layer of soil, oxygen is freely circulating here. This is a zone of aeration. So therefore, even sedimentation also occurs, small particles, then it percolates deep inside the ground and ultimately joins groundwater only. But before joining the groundwater, it should be purified completely. So that's why where groundwater table is very low, this is a land. Where groundwater table is very low, where plenty of sun, plenty of open land, that too sandy soil. Sandy soils are more recommended. Sandy soils have got good, they are good. Their absorbing capacity is very, very high, right? Compared to clay soils. So where land is capable of absorbing waste or consuming waste, sandy soils consume more waste than any other soils, more effluents than other types of soils or than any other soil. Therefore, they are best for disposing. Sandy soils are the best to dispose. Where sandy soils are available, where water table is very low, then where the main thing is in the absence of fresh water body, then we go for disposal by dilution. Otherwise, so this is one thing. So one problem is there with the disposal by dilution, sewage sickness happens. So land suffer with sewage sickness. So continuous application of sewage effluents on same land for prolonged period leads to sewage sickness. So that is one problem we need to address. Continuous application of sewage effluents on same land for prolonged periods leads to sewage sickness. Then how to revive? So stop applying sewage for some time. Stop applying sewage. Let the land dry completely. That means give rest to land. So once it completely dry, then plow the soil again to open up the pore spaces. To open pore space of the soil. Again it is ready to absorb. Pore spaces keep on filling with impurities. Therefore, once you plow the soil ground, completely pore spaces open up, again it is ready to absorb. So that is how we can revive. Revival, remedy or revival of land. How we can revive the land or reclamation when it is suffering with severe sickness. So I almost done this topic. If you have doubts, you can type there, we can discuss, or you can follow me. My WhatsApp number. WhatsApp number is not there. My group. WhatsApp group is there. Shiva Prasad Sir class. There you can follow me. So I have done this topic, completed in every respect, but unfortunately no one is watching. What to do? So Unacademy is offering discount, 23% discount they are giving on all the subscriptions from today onwards. So this offer closes very soon. Limited period offer till New Year. There is a New Year offer it is. So you can avail this offer to get maximum discount. This is important announcement from Unacademy side. You can enroll and you can use the code GATE Civil. So flat offer, this is 23% flat discount they are giving on all courses, both for GATE and ESE subscriptions. So with this I almost completed wastewater engineering. So tomorrow we'll start solid waste management and as well as air pollution. Tomorrow also I'll take 2 sessions. Possibly one session I'll take from 2 to 4. Another session I'll take from 6 to 8. Okay, be ready. Solid waste management is very, very important, and both air pollution also important. We'll revise fast, and day after tomorrow I'll complete your syllabus Friday. Then we'll quickly revise the content. Once again, in one session or 2 sessions, entire content we try to revise, especially formulae and all. How to make use of formulae, how to remember them. We'll list out all those formulae also. Okay. So by the Saturday, so 2 quick revisions. One revision by covering the concept we revised. Second is quick revision only with formulae. No numericals, nothing. We only talk about formulae, what is to be remembered from each topic. That and all we discuss in detail in two sessions. We will complete that. So quick revision, very quick revision, instant revision otherwise. Okay, you can also enroll free of cost. So this offer you can avail. So still time is there, December 8th, 15, 22, 29 they are going to conduct mock exams. So you can enroll at free of cost. Use code GATE Civil. So tomorrow we'll take 2 more sessions. I'll take 2 more sessions tomorrow. Two p.m. to 4 p.m. one session. And again 8 p.m. to 10 p.m. another session. So here we cover solid waste management. And we'll start air pollution. Air pollution you cannot cover in one session, it takes 2 sessions. Air pollution and control. Okay? That is tomorrow's schedule. Okay.